doing in chapter 5, inverse functions. I'm sure that they'll ring a bell. If not, hopefully the lesson today will help you. So I think we're going to look at it in three ways. With graphs, with the points. So numerically means by looking at points, and then analytically means looking at the equations and kind of finding inverses by hand. So the best thing to do to kind of get started is just, I'm going to give you an example of two functions that are inverses. So we'll start off with the first function is x cubed. So I'm going to use x cubed, and its graph looks like this. And what I'm going to do is graph the inverse of x cubed on the same graph. And I'll graph it maybe in green here. And so the inverse of x cubed, its graph looks like this. And this, we'll call it g of x for now. And this is the graph cube root of x, okay? So those two graphs are inverses. Okay. So it might be kind of hard to see, but there is some symmetry. I mean, if you kind of tilt your head to the side, you should see that they look like mirror images, not straight like this, but if I folded it this way. Okay, so if I folded one here, it should land on the other, and it's supposed to have that. Well, the symmetry it has, the graphs have, are about the line y equals to x, which runs right through here like this. So there's a line y equals to x. So both graphs, inverses, are symmetric about the line y equals to x. So we can kind of make that note. So two functions are inverses if the graphs are symmetric about the line y equals x. Okay? So they're both, they have to have the mirror image on each side of the graph. Now I'm going to show you what it means. Like what does that mean if we have the mirror image? So x cubed graph. If I want points on the x cubed graph, when I pick my x and I plug it in, I cube it, I should get my y. So for when x is 2, what should be the y on this graph? 2 what? 8. 2 cubed is 8. 2 times 2 times 2. Okay? Now, so the question is, if I fold this over here about the line and it lands on the inverse graph, the other graph, does anybody know what this point should be here? What should be the mirror point? 8. It is 8, 2, because the cube root of 8 is 2. And it is a point 8, 2. That is correct. And you can just check that. If you don't believe that that's a point, just do cube root of 8 on your calculator and you'll get 2. Okay? All right. Now, so something interesting should happen every time that we do this. So let's try another point. I know this is not the scale, but 3 comma what? Does anybody know what the y is on that graph? 3 comma what? What's 3 cubed? 27. 27. 3 times 3 is 9. 9 times 3 is 27. All right. If I fold and it lands over here, so again, we're folding about this, and we're trying to see what's the mirror point. Sorry, this is not, it should be the same distance here, but does anybody know what this point should be?
27.3.
27.3. That is correct. Now right here where they both land, they both meet and they land there, that's the point 1, 1. So you can't really tell. So each one has the point 1, 1 right there. All right. But what do you notice is happening from when you go from one function to the inverse with the points? The coordinate swap, the x and y swap. That's exactly right. It will always happen on inverses. Even down here, you know, so no matter what those points are. So if one graph has the point AB, what should be the mirror point on the other graph? BA, that's exactly right. Okay? So notice I'm talking about inverse functions in three ways. What do their graphs look like? So they should be symmetric about that line y equal to x. What's happening numerically? So here's the numerical. Numerically, if AB is a point on a function, then BA is the mirror point on the inverse. So all x's and y's switch as you go from one graph to the other one. All your x's and y's switch. Okay. All right, now we're going to look at what happens if we try to do this by hand. So, all right, can I erase the picture? Does everybody have the picture down? Okay. You guys are just writing those words over there. So, above the line are our topics for today, and below the line, I'm just starting the notes. So I didn't want to confuse the topics and the notes. Okay, so here's what we're going to do. We are going to go ahead and do the second bullet point. So if I give you a function, we're going to see how we find the inverse. So second bullet point, given a function, find the inverse. Okay, so this is what we're going to do. So we'll call this example 1, part A. We'll do this for each one. So let's say part A, let's say our function is 5x minus 2, and we want to find the inverse, okay? So now we're looking at inverses now with algebra. I don't know the other graph, but I want to find it. Well, let's just look at a point real quick. What would be a point? What's a point that this graph has? Like if you wanted to find a point on this graph, what would be one point? What's that? 1, 3. So you just pick an x. So Allison says 1, 3 is a point on this graph. Would you guys agree with that? She picked an x of 1, she plugged a 1 in, she got 3. That's a point. So the question is, what would be a point on the other one? Because I want to make sure you remember what happens between a function and its inverse. What should be a, 3 and 1. So whatever we get, the other graph should have the point 3, 1 on the inverse. Okay? Okay. So what is it that happens with x and y? They switch. And that's how we're going to find the other function. So now, given a function, how do we find the inverse? So we want to find the inverse. Well, over on the left, what other letter can I put here instead of f of x? Well, that's a whole different another graph. But what does f stand for? What does this over here stand for? The y. So instead of putting f, I'm just going to put y. Because, notice what I said here. So all x's and y's switch. So what we're going to do, if we want to find the inverse, so step 1, to find the inverse, switch all x's and y's. So wherever you see a y, you put an x. Wherever you see an x, you put a y. You're just reversing everything. Okay? So I'll make this x equals 5y minus 2. Okay? So Paige, is that normally how we like to write a problem? Do we normally like to write it x equals, or what do we normally like to have? Y equals. So it looks awkward like this. So we have 2 steps. So right now, once we switch x and y, we should have the inverse. This guy and this guy should be inverses, but the second thing we're going to do is solve for y, so we write it in a fashion that we're used to. So do the math to get y by itself. So take a second at your seat, and on this new function here, isolate y. Okay. Should just take you 2 seconds. Don't get too fancy with it. All right. So Leo, what would be my first step to get y by itself? What would you do first?
I did the inverse of -2, so I added 2.
So you add 2 to both sides. Very good. You got x plus 2 is 5y, and then what?
You divide by 5.
Divide by 5. So y equals x plus 2 over 5. And this is the inverse of f of x. So that's a lot to write, so we're going to make that simpler in a second. So you should have got x plus 2 over 5. Now, how can we check to make sure that that's, like, what could we do to kind of make ourselves feel better that that's right? Because, now remember, so Allison at the start said, okay, well, 1, 3 is a point on this original graph. So what should be a point on this graph?
3, 1.
3, 1, because 3, 1 is the flip of the points. So if we plug in a 3 for x, we should get a 1 for y. And if we get that, we should feel pretty good that our work is correct. So I'm going to plug a 3 in for x, so let's see. If I do x is 3, does y equal to 1? That's the question. Well, 3 plus 2 over 5 is 5 over 5, which is 1. So it feels pretty good that those are inverses. Okay? And it should do that for any points that you pick. So let's say, so now I pick 2. Say, well, if you plug in a 2, what's the point on this graph? On the original? 2 what? I don't get 5. Guys, come on. You do 5 times 2, and then you subtract 2. 8. Therefore, what should be a point over here? So let's see. If I plug in an 8, 8 plus 2 over 5 is 10 over 5, which is 2. So yes, this has the point 8, 2. Okay? And that's just a way I can double check. All right? Okay. But this is the process. So to find the inverse, you switch all the x's and y's, and then solve for y. Now, this, in math, where mathematicians are lazy, nobody wants to write all that junk out, inverse of f of x, all right? So, and we really wasn't called y, it was called f of x. So we have a symbol for this. So to say the inverse of f of x, we write it like this, f with a -1 like that of x is x plus 2. And this is red, if you want to like read it, you know, how would you read this? This is red, f inverse of x. That's how you read it. Okay. Okay. Let's do another one. I'm going to give you a function. You need to find the inverse. Now, remember, when you're solving for y, I like the terminology that Leah used. She says, I'm going to do the inverse. The inverse of subtracting is adding. The inverse of multiplying by 5 is divided by 5. The inverse of cubing is doing what? Cube root. The inverse of squaring is? The inverse of square root is? The inverse of cube root is? So you got to remember all that, right? All right, so let me give you another one, and you're going to try and see if you can find the inverse. And then what's a way you can check to see if it's right? Yeah, check your points, okay? Check a couple of points. So I'm just going to erase this one because this is really my palette to work right here. And then we'll do another one, and we'll look at it, okay? So remember your 2 steps. To find the inverse, switch all the x's and y's. So wherever you see a y, you put an x, wherever you see x, put a y, and then solve for y. That's all you gotta remember, okay? You guys have these steps written down. Good, okay. Let's try another one. So we'll call this one part B. So I'm gonna write the inverse below this that we got, because we got the answer here. So we found that f inverse of x was x plus 2 over 5. There's that one. All right, part B. And it doesn't always have to be f, it could be g, then you would be finding g inverse, but we'll just use f for now. All right, x cubed minus 4, you need to find f inverse of x. So remember, switch your x's and y's and then solve for y. So what's going to be your first step?
Swap the x and y's.
Yeah, so there's no y on this, but I'm going to change f to a y. So I'll make this y equals x cubed minus 4, right? And then I'll switch my x's and y's and I'll solve. So you're going to have to do a little algebra. You're going to be able to isolate y. Okay. So, Hank, just give me the first step so I make sure I'm on the right track.
So after you swap okay. I did add 4, or the inverse.
Just give me the first step. I just wanted just baby steps. What's the very first step? No. Look at your steps and see what the very first step is.
Switch the sign.
Switch x and y. So what the first thing I should do is write notes, especially when my teacher gives me a recipe. Hopefully you did that. Then we got to be able to go back and read the notes so that I can cook cake and not cook burritos, because I'm trying to cook a cake right now, okay? The steps on finding the inverse says first you switch what?
X and y.
So wherever I see a y, I'm going to put what? X. And wherever I see an x, I'm going to put y. Okay. You got that, right? Okay. That's all I wanted. Just that part. Now, once I switch to x and y, then you got to go through and solve. So make sure you got the steps written in there properly, right? Otherwise, it's going to be, and then you'll tell us the math in a second. I just want to make sure that we're all on the same. So this would be our first step. Because, why am I doing that? Because we saw that's what happened with inverses. When we look, their x's and y's switch. So that's why we're doing this. That's what allows us to help. Now you got to be good at algebra here. Okay, so that's step 1. So step 1, switch x's and y's. That just means wherever you see an x, you put a y. Wherever you see a y, put an x. Then second step, solve for y. Okay, now take us through, because this is where you were. You were ahead, right? So you take us through. What did you do first?
I added 4 to both sides.
Add 4 to both sides. All right, and then what do you do?
I did the cube root.
Right, so whatever this is, you gotta think, well, how do I get y by itself? Well, the inverse of cubing is cube root. So if you do cube root of the left and cube root of y cubed, so what should happen here when you do a cube root of a cube? All right, do you know why it cancels? So I'm gonna show you. Yes, basically that's what it is. I'm gonna show you another way. Cube rooting means the same as to the 1/3 power. So anytime you see the cube root symbol, it means the same as the 1/3. So if I just change it to the 1/3 power, because these mean the same thing, what happens when you raise a power to a power? You do what with your exponents? and 3 times a third is 1. So that's basically what's happened. But yeah, you're right, it just cancels out. So cube root of y cubed is y, and there you go. So this is gonna be a review of your algebra. And there you go. Now, what's the symbol we use? We're not gonna say y equals, we're gonna call it what? Or how do you write it? That's exactly right. You write it f inverse of x is cube root of x plus 4. Okay. So, Sydney, how could we feel good about, what could we do to, like, because we do the work and we get the answer. And the only thing with this, you don't have a book where you can go back, right? Back in the day, what did we all do? I did it. I looked in the back of the book to see what? That I get it right. And then a lot of times I would teach myself by trying to work to the answer. You don't have that right now. You've got this, everything's on computer. But we said with points should switch also. So I would just go back. What might be an easy point to pick on this one here? Like just make a point. What might be a point? What did you say? 1. So if I plug in a 1, what do you get? Plug a 1 in for x. -3. That means if 1, -3 is a point here, what has to be a point here? Let's see. So we're going to see if we get -3, 1. So do we have the point -3, 1? That means if I plug in a -3, I got to get a 1. So I'm going to check. I plugged in my -3. Oops. I get -3 plus 4, which is the cube root of 1. Does anybody know what the cube root of 1 is? 1. There you go. You don't have to do this, but I'm just showing you this because this is a way to check. And they may give you points. They may say, well, 1 -3 is a point on 1. What's that? What has to be the point on the other one? -3, 1. Okay. All right. Any questions on the process? So, step 1. Rachel, what do we do?
We switch the x's and y's.
Switch all the x's and y's. Step 2.
Step 2 is you isolate the y.
Isolate y. That's it. Maybe if you want a last step, just write with this notation here. Okay. Now notice there's something else on the board. So right now, I feel pretty good about this. I think you guys can, I didn't mean to cross that out. The other question we might get is domain and range. So one thing I want to say is anytime you have an x cubed graph, so just if I wanted to graph this x cubed, and you can graph it on your calculator, this graph looks like this. It crosses here at -4. So if I wanted to ask you about domain and range, what would you say is the domain of this graph? All real. What would you say is the range? Now guess what? Without even looking, what is going to happen is, as we go to this one, these two should swap. You just can't notice because they're both all real. Because if we switch all x's and y's, guess what? All the domain and ranges should swap. When we work some more problems, I'll be able to show you that. But right now, I can tell you the domain and range of this is all real. Both of them. If we graph it, okay? You can always graph these on your calculator. You'll see that it's all real like this. This graph kind of goes, it's going like this, I want to say. Oh, yeah, cube root of x plus 4. It's like this. And then here's your, you can always tilt your head. See if it has, okay. Yeah, I don't know. I mean, I'm just artistic that way. I'm able to make these pictures just like looking into the clouds, you know. All right, that's supposed to be true. So let's see. What is this? What's that say? 1 to 1. It is 1. It's short for 1 to 1, like writing out the word 1 to 1. So obviously we've got a couple more things here. So we've got 90% of the lesson done. At least you have the idea of, you know, okay, yeah, if I have a function, how do I find the inverse? If I have a function, how do I find the inverse? Let me put this answer here. Save these in your work because we're going to come back to them in a little bit. Okay. So now I have to erase the template. Next problem. We're going to work through this one together because I have time constraints because we got a video. Normally I would let you work it and talk about it, but we're just going to do this one together and see what the problem is and see that there is an issue and that how do we fix that? So on this example 2, the same thing, we're gonna say find the inverse, okay? Now, and here's our problem. We're gonna do just x squared. So y is x squared. All right. Now, we're gonna just work it together because I just want to save time and talk about the answer. So again, my first step, if I'm finding the inverse, would be, we would write it how? X equals y squared. Now, some of you may know this graph already, but if not, we can solve for y. It takes 2 seconds. Now, the problem now, once you introduce a square, when you do square root, you cannot do square root without doing plus or minus. When you can do cube root, you don't need plus or minus. But now with a square, we have to put plus or minus, and I'll show you why. Because if I look at this picture, x squared looks like this. All right, everybody good with that? Now, what I've got to do is I'm trying to picture in my head, what is the inverse going to look like? Well, the inverse has to be flipped about that line, like this. It's kind of hard really to visualize this. But if you only, when you go to solve for y, if you only do square root, you won't have enough. See, if I do square root of both sides, I get square root of x is square root of y squared. So I get just square root of x. Well, what does square root of x look like? Just that graph. It's the top half, right? It's like this. It looks like this. But notice the whole thing didn't flip. So in order to have the whole thing flip, I should put plus or minus right there. Okay? So just hang on. We're not going to actually, this is a bad problem. You'll see why it's a bad problem. It's kind of technically, what's the word I'm looking for? Like kind of, we're not getting the answer that we want. So there you go. Now look to the side. If I do plus square root of x and minus square root of x, this right here, that's what I did. I did plus square root of x and minus square root of x. Does that picture look like it's legit now? Does it look like that's the, if I flip that graph, I get that graph. But the problem is this, the title of the lesson. See if you can figure out where the contradiction is. The title of the lesson is Inverse Functions.
It's not going to be the same. It's not going to be the opposite.
Anybody know what's wrong with this blue graph? Yeah? It's not a function. It fails the vertical line test.
Oh,
See? It's not a function. But the problem was over here. See, so like for instance, over here, you have these points, say 2, 4, and negative 2, 4. But when you flip, what point does this become right here? 4, 2, very good. And what point does this become? 4, negative 2. So what happens is, it's kind of like the error starts here. It's the original graph that we have. See, notice you can't have 2 points with the same y. Because if you have 2 points with the same y, when you go to get the inverse, you get 2 points with the same x, see? And it's not a function. So the problem lies in this original, they won't give, in the homework, they can't give you this. They can't give you this picture, and they won't give you this and say, find the inverse. I'll show you what they'll do. But they can't give you this because this original is what we say is not 1-to-1. And I'll explain to you what 1-to-1 means. Okay? So it's not 1-to-1. So let me just make sure I rehash all this again. Because this graph has 2 points that have the same y, we say that this fails the horizontal line test. Think when I go to get the inverse, those 2 points will flip, and there'll be 2 points with the same x, which now this over here is not a function. So in order for a function to have an inverse, we say it has to be 1-to-1, which means it has to pass the horizontal line test. So let me first write that out. Problem is, all right, I'm going to erase these notes here because I just need room to write. So for function to have an inverse function, and I'm gonna underline function, inverse function, double. So for a function to have an inverse function, the original function must be 1 to 1. Now, you can write it with the words 1 to 1, but mathematicians are what? Lazy, so we write 1 dash 1. Okay? All right? You feel okay?
Yeah, I'm fine.
Okay, just making sure. I can only see this, so sometimes I'll just try to make sure you. All right. So where was I? All right. So now, what does it mean to be 1 to 1? This is what it means. To be 1 to 1 for every. I'll write the words out, but I'll just show you the picture. It's easier. For every x, there is 1 y, and for every y, there is 1 x. The easiest way to do this is must pass VLT and HLT. What's VLT? Vertical line test. What's HLT now? Yeah. So V is vertical line test, and HLT is horizontal line test. So that means if I draw a vertical or horizontal line, it can only cross once. Okay, so so they're gonna just give you a graph, or they're gonna give you something that they're gonna say, is it 1 to 1? So let's do that before we do anything else. Okay, and make sure we know what 1 to 1, and then I'll come back to this problem and show you how you'll be asked to work it. So, the first graph I gave you today, 5x minus 2. Here's the graph, looks like this. Okay, so what am I gonna do? This is all I'm gonna do. I'm gonna take my pencil. Yeah, that's exactly what I'm gonna do. Sydney showed us. Look, I'm gonna see, first of all, is it a function? So does it pass the vertical line test? And then is it 1 to 1? Does it also pass the horizontal line? Means if I draw a horizontal line, you can only cross once. So is this 1 to 1? Yes, and thus it had a function that was an inverse. Okay? Remember your x cubed that we did. Let's just say I do x cubed plus 2, and I do that. Let's look at that picture. Okay? And you can, I would encourage you, type them in on your calculator and then just move your pencil around. So does this look like it's 1 to 1? All right, if I draw a vertical line, it only crosses once, and a horizontal line only crosses once. Okay? All right, I call this the Mcdonald's graph. So why don't you take a second and plug it in on your calculator and see what it looks like, then you'll know why I call it the McDonald's graph. Not because it looks like cheeseburgers, I know we're hungry, but it doesn't look like cheeseburgers. You're supposed to laugh at the math teacher's awful jokes. You don't like cheeseburgers? Please tell me you like tacos.
Depends on the place.
I mean, homemade tacos are the best. We do Taco Tuesdays every Tuesday at our house. No, he tells us, he says, it's Tuesday, we gotta do tacos, Taco Tuesday. The best tacos I've ever had are near the ocean. I've had like mahi tacos and all that, shrimp tacos. All right, why am I calling it the McDonald's graph? Looks like an M. Got the oldest golden arches, boom, 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 boom. But the reason I'm asking you, is it 1 to 1? No, very good. It is a function because it passes what? Vertical line test. It's a function. But it's not a 1 to 1 because it fails the horizontal line test, which means its inverse would not be a function. Okay? So the bottom line is, so they're gonna ask you, they're gonna say, is this 1 to 1? You're gonna be yes or no. So the best thing for you to do is just draw the graph, okay? Real quick. No, because it tells vertical line test. Very good, all right. Now, how are they gonna circumvent all the rules? And how are they gonna give you an x squared and it be 1-to-1? So this is what they're gonna do, all right? Here's what's gonna happen. Now, example 3. Given f of x is x squared and x is greater than or equal to 0. Is f of x 1-to-1? If so, find f inverse of x. So what's different? X is greater than or equal to 0. Notice, they're not giving you the whole graph. They're only giving you this part. So right here, when you do this, remember when we did piecewise, a couple of sections ago, when we did pieces, remember, it's a piece of this graph, it's a piece of that graph. So they haven't given us the whole x squared. They've chopped it. So this is telling you where they've chopped it. Keep only this part. So let's look at this real quick. So x squared normally is this. But they're cutting it, they're slicing it at 0, right here. And this means we want this graph, but only for x greater than or equal to 0. It means that it only wants the right-hand side. So this equation goes with this picture. So I have to slice it in half there. Now I look at the picture. Is it a function? Yes. Right? Does it pass the horizontal line test? Yes. What's the domain of this? It tells you. 0 to infinity, yeah. What's the range of this? Let's do this, because I want to show you what happens between the two. Let me just change it and put a +1. So what would that do to the picture? Move it up 1. So I want to just do this, you'll see, on purpose, okay? So what's the range for this picture? 1 to infinity. Yeah, you'll see why I'm doing this. I'm making a point here. Okay, now, all right, so is f of x 1-to-1? What would your answer be to this? Yes, just put a yes. I don't know what the computer will do. Because it says for x greater than or equal to 0. You only keep the graph for x greater than or equal to 0, just like piecewise. So if it puts this here, guys, if you see this little x greater than, x less than, this is restricting the domain, which means it's going to chop the graph. It's only going to keep the part that it tells you. So you only keep the part of the graph that it says. Keep the part for greater than or equal to 0. Okay, now go through your steps. So it's x, I changed it to x squared plus 1. So now make it y equals x squared plus 1, but you got x is greater than or equal to 0, and go through your steps for finding the inverse. Because it says, if so, find f inverse. So now go through your steps that will give you f inverse. Switch all your x's and y's, even on that. And now you'll see why we don't do plus or minus when we do square root. And you can graph both at the end and look at the picture on your calculator. I would encourage you to do that. All right, so it's because I'm videoing and I'm just going to work along with you. See, Maria, what's my first step when I find inverses? What should I do? And I'm going to switch it even over here on the inequality. I'm going to put y is greater than or equal to 0. That's going to tell me when I do square root to not do plus and minus, okay? What should my next step be? So now just save this over here to the side. What should be next? Subtract 1. X minus 1 is y squared. All right? Remember, y now has to be greater than 0, which means y has to be positive. Now, when you wanna get rid of a square, you normally do what? But you're not gonna put the entire plus or minus, and because of this, because y has to be bigger than 0, which means when you solve for y, you don't want a negative answer, so I don't put plus and minus, I just do plus. That's where this is gonna be a little tricky. See, I can't put plus and minus and it won't be a function. I either do plus or I do minus, okay? And then that's it. So because of this, I don't do plus and minus, and then that's it. I save this. Should have got square root of x minus 1. And if you draw this on your calculator, it's right here. So I want you to see what happens when we get this answer. So when we get this answer, so for our original, that's the domain of f and that's the range of f. Now let's look for f inverse. Here's our f inverse, square root of x minus 1. So can you do the domain of f inverse and the range of f inverse? So let's look. Everybody see that I drew the graph real quick. So what does the domain look like? No. Look where the x. Yeah, 1 to infinity, right? And what does the range look like? 0 to infinity. Now, look at this is why I did this one on purpose. Look at the domain and range of the original, and look at the domain and range of the inverse. What happened with the two? They swap. Does it make sense that they swap? Why? And what's special about inverses? What do you swap? You're switching all the x's and y's. So if you're switching all the x's and y's, then it should make sense that your domain and range should swap. Because your domain are all the x's and your range are all the y's, and that will always happen. So when you go to find the inverse, so if it says, if you know the domain and range for your original function, then you already know what the domain and range for your inverse has to be. They have to swap. Okay? All right. I have one last thing, and then that's it. So we've done, so you may have questions on this chopping, but that's what makes it one-to-one, okay? All right, so last thing. We can use this one. Let's see. What was f? F was x squared plus 1. And f inverse is square root of x minus 1. All right, here's what we're going to do. There's a way to prove, this is at the very end. Prove f of x and f inverse of x are inverses. Now, to you, I know you're thinking that that's what we just did because we just found it. But that's not what they're asking us to do. When it asks us to prove this, we're either going to do f of f inverse, or we're going to do f inverse of f. Remember, this was the last section. This is what you did last in 5.1, composition. And what should happen is, whichever one you do, you should always get x. Because it's like you're going in a circle. You switch x and y. The y is on one, or the x's are the x's on the other. So if you put one into the other one, it doesn't matter which one you do, you should get x. And if you get x, it proves that they're inverses. So I'm just going to do f of f inverse. I'm just going to do this one. So remember this process. This function goes into this one in place of x. And if I simplify and I get an x, just only an x as the answer, then they're inverses. Okay? So I'm taking like what we did in the last section and tying it into this one. All right, so can you tell me what to write if I'm going to put this into there? All right, very good. So there, she's exactly right. Sydney's right. That goes in there, so we're going to square it, so it goes in place of x. What happens when you square root, Sydney? That's right. So you got x minus 1 plus 1. What's x minus 1 plus 1 is just what? Check mark. Good. Let's check the first two I gave you today. What was the first two? And it would have worked the other way. Let's say you had stuck this into here, you would still get X. Okay? Because look, if I plug this in, what's gonna happen to the +1 and the -1? Yeah, really good. Let's check the first two we did today. What was it? F of X was 5X, what, -2?
Yes.
And F inverse was X + 2 over 5?
X2.
Yeah. So you do one, so it doesn't matter. You took one, plug it into the other, see if you get X. So show that F of F inverse of X equals X, or show F inverse of F of X equals X. Doesn't matter, you can do either one. Plug one into the other one, you should get X. I'll do both. This is our last problem. This is like a refresher on your composition that you had in the last section with your inverses. Now, why is this the rule? I mean, it takes a little bit of time for me to derive. I just want you to, on this one, due to time constraints, just trust me on this rule. Okay, so let me do the first one. I'm going to do F of F inverse here. I'm just going to start writing, so let's see. That means F inverse goes into F. So 5 times X + 2 over 5 minus 2. Let's see if my setup looks good. Right? Everybody see I put parentheses where I subbed in. All right, what would you do first, Sonari? Yeah, but if I distribute it, what's going to happen with this 5 and this 5? If this one's up and this one's down, yeah, so I'm just going to cancel them. So once I cancel that, leaves a 1, so I really don't need the fraction. X + 2 minus 2. Then what can I do? 2 and 2 cancel. I'm left with X. So what happens if you didn't get X, Allison? What does that mean? One scenario, if you do this and you don't get X, then they're not inverses. Guess what the other scenario is? You made a mistake. Go back and check your work. Okay? Now, remember what I said, it doesn't matter which way. You could do F inverse of F. So now I'm going to take this one and sub it in here. Okay, so it should be 5x minus 2 plus 2 all over x. I think, oh, I'm sorry. Not over x, over what? 5. All right, what would happen first?
2's cancel.
2's cancel, you're left with 5x over 5. What happens to the 5's? Here's what they do in my math book. It just says find F of F inverse. Well, you know, what does the answer have to be? X. It has to be X. Okay. Write that down. Yeah. That's what I did. I was surprised. I was like, okay. So a couple of questions. If I have a graph and the inverse on the same picture, what are they symmetric about? Y equals X. If 4, 2 is a point on one function, what is the point on the inverse? 2, 4. How do you find, I give you an equation, how do you find the inverse? What do you do? Switch to Y and X and solve for Y. I give you two functions and I say prove their inverses. You take one and you put it where? In the other one, and you should get what? Okay. What am I missing? Oh, here's a graph. Is it 1 to 1? No, it fails what? Horizontal line test. Here's a graph. Is it 1 to 1?
Yes.
Yes. Still kind of right. Yes. Okay. All right. What about this one? No. Okay. If it's 1 to 1, then does it have an inverse function?
Yeah.
Yes, that is a truth. You got it. You guys are awesome. Okay, end of